An arithmetic sequence is a sequence that is formed by addition. So, for example, we could have 3, 5, 7, 9, 11, and on it goes. So notice that every number, every time we step forward one position, we add 2. That makes an arithmetic sequence because we're adding 2 every time we move. That is called the common difference. 2 is here. Another example, if I said 10, 15, 20, 25, and on and on and on, every number is created by adding 5. And again, that 5 is called the common difference. Often when you get an arithmetic sequence, you're looking for a particular term. So if I gave you a sequence, say, that started at 3 and added 4 every time, and I asked you for, say, the 20th term, the idea here is that I'm starting at 3. Every time I move forward in the sequence, I add 4. And because 3 is the first term in that sequence, I only have to move forward 19 places. So the 20th term would be starting at 3, the first term, and adding 4 19 times to it to get to the 20th term. So 4 times 19 is 76, plus 3 is 79. So another way we could say that is you would say that the 20th term, written as a sub 20, is 79. So another example, if I had a sequence that started at 8 and added 3 every time, then if I asked you for the 15th term, a sub 15, I would start at 8. Every time I move forward one position, I add 3. Because I'm starting at the first term, I only have to add 3 14 times to get to the 15th term. All right, 3 times 14 is 42, plus 8 is 50. So the 15th term, or a sub 15, is in fact 50 in that sequence. 2 more examples if you need them. If you want to see how to use an equation to make an arithmetic sequence, fast forward ahead. So here is another example. If I had a sequence that started at 100 and was decreasing by 6, and I asked you for the 18th term, then I would write it like this. I start at 100, I'm taking away 6, and again, because 100 is the first term, I only have to move 17 places in that sequence to get to the 18th term. So 6 times 17 is 102, and 100 minus 102 is negative 2. Last example. If I have a sequence that begins at 22 and adds 7 every time, so if I was looking for the 40th term, a sub 40, it would be the first term, 22, and I add 7 every time I move forward one position, and I only have to do that 39 times because I'm starting at the first term. That will get me to the 40th term. The result of this is 295. We can write an equation for an arithmetic sequence by using that subscript. So if I give you a formula, a sub n equals 7 plus 3 times n, then notice that a sub 0, that means I plug in 0, it would be 7 plus 3 times 0, which is 7. A sub 1 would be 7 plus 3 times 1, or 10. A sub 2 would be 7 plus 3 times 2, which would be 13. And I can go anywhere I want. I can say, hey, what's a sub 10? That would be 7 plus 3 times 10, or 37. One more example. If I had a formula that was a sub n equals 7 minus 3 times n plus 1, and I asked you again what a sub 0 would be, that just means I plug in 0. So that ends up being 7 minus 3, which of course is 4. A sub 5 would be 7 minus 3 times, again, I'm just plugging in 5 for n, 5 plus 1. So that would be 7 minus 3 times 6, or 7 minus 18, which is negative 11. A sub 5, or the fifth term then, is negative 11.